everyone, let's see how to solve this problem. Count digits. So given a number n, so we have to count the number of digits in n which evenly divides the n. So we have to return an integer total number of digits of n which divides n evenly. So in this example, so n equal to 12. This is the input. Output should be like if the how many digits in the given n, it's evenly dividing this 12. If we take this digit 1 from it, it should be divide the 12, and then digit 2 also divide this whole number 12. So we have to count those how many digits are dividing this number, and then we have to return that output. So in this example, 1, 2, when both divides 12, so it leaves the remainder 0. So the two digits are dividing here. So the output will be 2 here. In this example, only 2 only divides this whole number. So the count is 1. Here 2 and 3, none of them divide 23 evenly. So none of the two digits divide this whole number. So the count is 0. Time complexity for this problem is order of n, and then space complexity is order of 1. Let's see how to solve this problem. Usually when the question is asked to count the digits, now we have to think of the logic like we should have a counter, and then we have to proceed. So initially I'm just declaring one counter. It is initially 0, and then I'm just storing a n in a one variable. Let us store in a, and then we have to loop through in a while loop. Until the a value, in this a only we have this 12. Until the 12 get into 0, the while loop will be executed. So inside the while loop, what we have to do means we have to take one digit, and then we have to check whether it is divisible by nth value or not. So usually we check modulo 10 for the remainder, and then to remove the last digit we use the divided by 10. So let's code for this. I just store it in a variable like this will fetch the last value, that is 12. In this case 2 will be in the, it is stored in the d variable, and then a modulo 10 this will modulo 10 will usually takes the last element. And what we have to check means now the 2 is divisible by 12 or not. So in this if condition we have to check. Sorry, n modulo, we have to check this n value, n only 12, 12 modulo this last value we are restored in d variable, and then what we have to check means equal to 0. If we divide means it should be divisible, that means n modulo d equal to 0 means we have to increment this counter. After incrementing the counter, we have to Once we checked this two digit last digit, so we have to remove this digit. For that a equal to a by 10. So this will actually remove the digit. Modulo 10 take the last digit. To remove the digit, divided by 10 we use. So likewise here it has to work. For now the 2 will be removed and then 1 is checked. So 1 is divided by 12 means it will check in the if condition, and then if it is divisible means it will increment the counter. For this example, the counter will now become 2 because 2 is also divisible by 12 and 1 is also divisible by 12. So counter will be 2. So finally we have to return the count. Before while we checking the d n modulo d, we also check whether d is not equal to 0. If this both the conditions satisfies means we have to increment the counter, because when we are taking modulo, d value should not be 0. That we have to check here, d not equal to 0. So I just compile it. Okay, the expected output came. Okay, all the test case passed. Thank you.